let's just start with our introduction to machine learning. Okay, so like I already briefly explained, I will tell you what the structure of our internship is going to be. So basically, we are going to have two different phases. In the first phase, we'll be learning the basics of Python, right? Starting all the way from what are variables, all of that, and to understanding what are classes, objects. So we'll do all of it, and then we learn pre-processing of data, which is very crucial. When you're working with any algorithm, pre-processing is always the first thing that you will do before you start, regression or classification problems. So and after we understand the pre-processing, which is going to be common even if you're working with a regression or a classification problem, after that we will learn many regression algorithms, and then many classification algorithms. And after that, we'll have a brief introduction to what neural networks are, so that once you're done with this course, you'll also know what path you should continue in for more understanding in this domain. And after that, so the phase one will basically be for 20 days, and phase two we'll have the project work that you'll have to do. So that will be for 10 days, and we will split that among two different projects. So you'll have project one and project two, and you'll have 5 days for each of them. So that will be the structure of our internship. Okay. So some months ago, I remember my mom came complaining to me about how she's receiving so many messages and notifications about all these jobs in data science. She kept saying, "There's so many messages that's coming. This is not even related to me. Why am I getting all these messages?" And I have not even like looked around for something related to that. So it makes no sense. Uh, then I was also very surprised when she told this to me, and then I checked her phone. I did not understand why she was getting that either. But then later I realized that her account was logged in my laptop's Chrome browser. Okay. And so whatever like I have been searching, she has been getting updates regarding that on her phone. And then it made sense. Now, when we think why is this happening, many of you, might think that cookies are being enabled in your browser. So basically, what cookies do is they remember which user is connected with us. Okay, so that is what cookies do. Now, this is like partly true because HTTP is anyway a stateless protocol, and it uses the assistance of cookies to remember the users and their movements. But cookies will not help in understanding what interests a person has, right? So that cookies won't be helping. So all of this is happening because of a machine learning algorithm that is running in the backend. So we notice that in these days, like there's a lot of opportunities that is increasing exponentially in this field. There's a lot of demand for the skill sets required here. And it is not just that in our it's not just in the technical field that this buzz is increasing, because when I have been talking to my friends who are not even from a computer science background, so like people in the law area or in the tourism section, so all of them were also, what's this machine learning thing? So all of them have a little idea about something related to artificial intelligence and stuff like that. So even if we don't have a very in-depth understanding about what machine learning is, right? At least being engineers, it is important and crucial that we have a little understanding about what machine learning is. So that's precisely what we're going to be doing in today's session. Okay. So in today's session, we'll understand briefly what machine learning is and how did it come, all that. And then we'll jump into the installation that we'll need for our program, and then we will start with implementation and all of that. So first we're going to understand what exactly is machine learning. Then we're going to have how is this different from the usual programs that we already write, right? Because all this time we have been using the traditional programming technique. So if we have started with machine learning, then there is something different and there is a need that caused it. So we'll understand that, and then we'll clear out some common misconceptions that we usually have. And after that, we'll understand, the different types of machine learning, the examples and all of that. And then we'll prepare our laptops so that from next class, we can dive in and directly with the implementation. And finally, if any of you are having any doubts, you can always put it in the chat section and I will clear it out. Okay, so that'll be the agenda for today. So first, most important question, what is machine learning? Now, machine learning, Wikipedia perfectly gives this definition where it says that machine learning is the study of computer algorithms and it improves automatically through experience, right? This is very well said. But then for a new person, I don't relate to this, right? So maybe let's understand how this is different from what we already do, right? So when we understand, we don't know what's machine learning, but we know something else, what we use computer and programming to do. So we'll compare that with how machine learning works and understand the difference so that we understand better about what exactly is improve automatically through experience. Okay, so generally when we expect the computers to do something, right, we program them to do it because computers cannot take decisions or anything of that sort on their own. Computers will blindly just follow what we say. So these instructions that we give is basically through a program, so we tell exactly what is supposed to be done. So every we provide like a step-by-step instructions for all the required combinations, right? We'll already think about what are all the things that the computer might encounter, and for all those cases, we'll try to write a program on our own so that any situation that the computer encounters, it'll be able to solve it. So that is what we do with traditional programming, right? So here you can see that the input for the system is going to be the program, that is the instructions that we write, and then there is some sample data that is already there. And with this data and program, this is basically like the input. So with that, we get an output, right? So this program is going to help us get this output from the particular data. So that is what happens in case of traditional programming. But in case of machine learning, it's a little different. Okay. So what we're doing here is that we already know what's the output, we know what is the input. We're giving these two things to the machine, and we're expecting the machine to come up with the algorithm so that for the respective data, it says the output is the correct one, right? So we're trying to design the algorithm. We're trying to make the machine design the algorithm. Okay, so but there is different type of programming that we do in order for the computer to do develop its understanding and understand similarities, differences between this. Okay, so now I'll give you like an example. I'm sure all of you have used Fitbit at some point in your life, or you've seen someone use it, or you have this application that tracks the number of steps that you're taking, right? So this is definitely happening because it is an approximation. Okay, it is not really or exact number of steps that you're taking, right? There is nobody standing next to you constantly following you and seeing how many steps you're taking and giving that as an input to the system or something like that. So nothing of that sort is happening. So it is an approximation that they're trying to find out how many steps you're taking. Now, how could we solve this problem with traditional programming? Okay, so with traditional programming, what we can do is basically we will have like different samples and we'll Google out and find what is the average speed a person walks in. Okay, so we'll find out the average walking speed of a person, and then with the GPS module, we can find where the person starts and where the person ends at every point, and see that speed. If that speed comes in the same ratio as the speed of a person walking, so that we can differentiate whether if the phone is moving, is it moving because he's traveling on a bus, he's cycling, or is it because he's walking? So we understand that difference, and once we know that it belongs to that same speed thing, then we'll basically, depending on the distance, like say 1 kilometer is traveled or 100 meters are traveled, we'll approximately try to give a number of steps for that. So Like that, we'll add and find out the number of steps that the user is taking. Okay, so this would be if we were doing it with traditional programming approach. But if we were doing the same problem using the machine learning ideology, then what we would do is we give the computer, right? We'll give the computer, like say, I'll give 10,000 data, 10,000 samples data of all these people who are walking. And I'll give 10,000 examples of all these people who are running. Okay, so I'll give these two different data to my computer. And I would have already labeled the first 10,000 as that this person is walking and the second 10,000 that this person is running. So the computer will see regarding every input data whether the person is running or the person is walking. So it'll go through all the 20,000 data that we have given. And then based on all of this data, it'll try to understand why certain things have been labeled in a particular manner, why certain variables are saying that they're walking and it is not running. So it do this for all the 20,000 things, and it will try to develop its own understanding on what parameters or what is more important to understand whether a person is walking. So once this is done, when you give a new sample of a person, right, then it will automatically predict whether the person is walking or running. And once it predicts it's walking, it will also predict the number of steps. So I hope it's clear to all of you on how traditional programming is different from the machine learning approach. Do any of you have any doubts? If you're having any doubts, you can put it in the chat section. And if you're not having any doubts, please put a message no in the chat so that I know I can go ahead. Okay, awesome. So now we'll try to clear out all of these common myths that usually buzz around before we go to the different machine learning types and all of that. It's better to first remove this out of our head so that without any confusions we can go ahead with the topic. Okay. So the first thing is that machine learning can be used anywhere. Now, this is definitely not true, okay? So, it is for an obvious reason that if you have a simpler way to solve a problem, you wouldn't do it the complex way, right? It's like when you can eat your food directly by bending your arm, so you'll eat your food like that. You will not put your hand behind your neck and try to eat. It's a very common thing that usually elders say. You're doing it in the complicated way. Just go straight forward, right? So the same thing about here as well. And also another important thing is that machine learning algorithms, like you would have heard me tell last time that we gave 10,000, 20,000 different samples. So basically, for any machine learning algorithms, most of the time we require a lot of data sets so that you get good results. So you need that data, right? And there's a lot of time that involves in getting this data. And after data, you need a lot of computation as well, right? So all that is also required. There is a trade-off between whether you want to have a lot of computation during training or during testing. So in a nutshell, you need a lot of computation. So you need a lot of hardware and you need a lot of data as well. So these are two things that are very essential for a machine learning approach to work. So if you can do it by a simple if else condition, say, or you can do it by some mathematical formula calculation, it is always better to do it that way rather than doing it in the complicated way. But some type of problems demand you to use machine learning algorithms, and there is where we try to use this as well. Okay, so you can use it everywhere, but do you have to use it everywhere is what we need to think. Next, there is all this other thing that is machine learning is same as artificial intelligence. There's a lot of confusion between these two words because both of, like, the mainstream people or in the media, they tend to use it very interchangeably, right? So these words are very closely related. So basically what artificial intelligence is, it is a computer, that is capable of making decisions by learning. So that is what is artificial intelligence. Now, an example of artificial intelligence is, how do you understand whether artificial intelligence is, here? So that is through the Turing test. Okay, so this is a very popular test. What exactly happens here is that, say there are two different rooms, and inside one room there is a computer, and inside another room there is another human being. Okay, and there is another evaluator or a tester who's there outside. Okay, so this tester is coming up with different questions, and he's passing the same question into both the rooms. Okay, imagine like he's slipping a question paper into both of the rooms. Okay, like slipping through their doors. So now and then, so something happens, and then he gets an output from both of them. Okay, so when he gets an output from both of them, if he compares these two outputs, and if he's not able to differentiate and understand which output came from the room which is having a computer inside, and which output has come from a room that is having a human being inside, then we say that we have achieved the goal of what artificial intelligence is. So basically, artificial intelligence is a huge domain which is having a lot of other topics other than machine learning also that is under it. Okay, so machine learning is like a subset of what artificial intelligence is, and other things that we have in artificial intelligence are like computer vision, natural language processing. So all of these are not necessarily a part of machine learning, but they're all parts of artificial intelligence. Okay, so artificial intelligence is the huge parent structure in which machine learning is a small component. So basically, what machine learning is it is their algorithms that power artificial intelligence. Basically, they enable a computer to learn without explicitly being programmed. So that subset is what happens with machine learning. Now again, like similar to machine learning and artificial intelligence, there is a confusion between deep learning and machine learning. So now again, and similarly like machine learning and artificial intelligence, here also deep learning is a subset of what machine learning is. Okay, so basically all the machine learning algorithms that use neural networks to solve this problem, they are all basically deep learning algorithms. Okay, so machine learning algorithms, all of them need not use neural network approach. Okay, so the various algorithms that we will learn. Okay, and basically one of these one of the approaches in which we can do it is also through neural networks. And if we are working with neural networks, then it's called a deep learning algorithm or a deep learning approach. Otherwise it is just a machine learning approach. So during the course of our internship, we will be working rigorously with machine learning algorithms, and then we'll have a brief introduction to neural networks where we will be understanding two deep learning algorithms as well. Okay. So, and another misconception is that algorithms are everything. Now, they're definitely an essential part of what machine learning is, so we can't deny that, but not the most important part. Okay. So, with that being said, let's say we have a very large, okay, very huge data set, and this data set is having like enough examples of every possible situation that the machine can encounter. Okay, so this situation is very highly unlikely. Okay, because for you to get a data set that has enough examples of every possible situation, so think about it. If there are so many options that can be there, and for each of the option you need like 1,000 2,000 samples minimum, right? You need sufficient samples for each of them so that the computer understands, right? So if we have a data set which is that huge, then any of the machine learning algorithms that we have learned, right, all of them will perform equally well. So that is very important. So basically, any algorithm I choose, if my data set is awesome, okay, my output is going to be perfect, and it's going to be the same thing for all of them. Okay, but the reality is that we don't have such a good data set, and there are always problems in the data set that you're collecting, because that is limited to say memory or how much effort a person has put in getting the data and how much data we can actually collect. So because of that, different algorithms, give you different accuracies or different scores on how well they're performing when we work with this data, right? So you understand how really crucial the quality and the quantity of the training data is. So that is very, very important. Hence, we can say that an intelligent machine is impossible if we don't have very good training data, and we have ML algorithms, and we also have a human in the loop who's basically connecting all of this together, right? So basically, for an intelligent system, all of these three things are equally important. So we cannot say that algorithms are everything. Okay. Now, machine learning will take over human work. Now, this is a very common major fear that it will replace human beings, right? Now, with machine learning, right, there's a lot of tasks that can be automated, and it will definitely and it can perform even social activities to an extent. Like you guys would have seen in the news how this latest one of the robots got citizenship, right? So it is quite possible that it will extend to an extent it can replace certain, even in social places you can replace humans. But then another important thing is it will definitely create opportunities for new job roles, and it will also develop the need for a new skill set. That is the main reason why there is such a bloom for this domain. All of a sudden there is so much demand for people with these skill sets. All this gives us a lot of new job opportunities, so they'll definitely not take over us. Okay. And another thing is that artificial intelligence can undertake any task. Now, maybe one fine day, this is possible, okay? But right now, artificial intelligence is still in a very infant stage, and it's trying to augment what human intelligence is, okay? So the present systems are, how they work is like if you give, say, an input X, right? It will give you an apt response Y, okay? So that is how it works. It is trained with these X and Y things. Now, from the daily news of what artificial intelligence advances we see and all of that, we can think that, oh my God, computers are on the urge of, seeing, speaking, and then reasoning everything, like how well we do it, right? But, and after which they'll like quickly leave us to dust, right? But see, this is not really true because we've definitely come a very long way from past 50, 60 years of artificial intelligence, right? These ideas, concepts were there even 60 years before here. But you can see at what stage they have reached after 50, 60 years. So they have come a very long way, and no doubt that machine learning has played a very huge role in this, okay? But we certainly have a longer way to go, and computers can do like narrow tasks very well, okay? So they can behave like expert systems. So in the particular domain that they are trained in, they can be very good at it, but they cannot they still lack common sense, right? And nobody really knows how to teach them common sense. So this is what is makes us different and makes us unique as well. So now that we've cleared out all the misconceptions, let's quickly recap what we've understood about machine learning, and then we'll understand, the different types of machine learning. Okay. So basically, machine learning is an application of artificial intelligence, and it provides the system's ability to automatically learn. So I hope now you learn from experience. So I hope now the Wikipedia definition makes little more sense. And so basically, without we explicitly programming every time, it will learn through experiences, right? So that is the idea behind this thing. And how does it learn through experience is basically that we give a lot of samples. It will go through all these samples, look out for patterns, find out similarities, differences, and then try to understand why a certain thing is labeled to be something, and develop its own understanding so that for future examples it is able to predict a particular value. So that is essentially in a nutshell of how machine learning works. Okay. Anybody's having any doubts still here? You can put it in the chat section. If you're having no doubts, then let me know about that as well. Okay. So then now we can understand what are the types of machine learning. Okay. So basically they can be classified into three different types. Okay. We have supervised learning, and then we have unsupervised learning, and we also have reinforcement learning. So basically machine learning is having three different types, and these types are supervised, unsupervised, and reinforcement learning. Okay, so first we'll go through supervised learning. So I hope all of you are able to see this flow chart. Okay, so basically what happens with supervised learning is there's a lot of training data that is there. So it deals with all of these training data. Now what happens in this is, you can see there's a lot of raw input, right? So we have a lot of, you see, green circles, and then there are some red triangles, and you can see these purple squares. So we have a mixture of different data. Okay, so you assume that all of this, signifies something. Okay, they're all basically examples of some category, and you can think that maybe the category is that all of them are all red triangles is to be put together, and all green circles are supposed to be put together, and we have all the purple squares that need to be put together. Okay, so let's imagine like that we have like a mixture of, and this data is like a very huge data, and it is a mixture of all of them. Okay, so that's usually how our input data is. Okay, we have a, if we have it in a tabular format, so how it would be is that we have these lot of rows, and each of these rows basically will have one of the columns which is going to be our output column, which basically we want to know what we have to get. So output is already known, so the last one will have that, and there are so many other features that they've given. So this is how usually the input data will look. Okay, and the most important part about supervised learning comes here. Okay, so there is a supervisor who will already, who will prepare this training data set, and he would have already labeled each of these data to its desired output, right? So basically in this example, if you see, if there are red triangles, he'll, put that into one category. He'll put all red triangles together, and he'll name all the red triangles as, say, one. Okay, because the important thing is that machines don't understand letters, words, and all of that. It'll only understand numbers. So any categorical information that we have will always be encoded into a number. So let's imagine that all red triangles, the supervisor has named it as 1, and all the green circles he has named it and numbered it as 2, and all the purple squares he has numbered it as 3. So basically one supervisor would have already done this. So main thing about supervised learning is we already know all of these input data, and the target is basically what output we are expecting, right? That is already known. So that the supervisor would have already done. Now when you give this data to the system based on the algorithm that you choose. There are various algorithms that we can work with, like support vector regression, support vector classification, random forest, decision tree. So there are various algorithms. So depending on the algorithm, some processing is done, and based on this processing, we get the output of what the person is basically trying to do. Okay, so that is how supervised learning works. Okay, so we can, and in supervised learning again, we have two different types of problems that are solved. The one that we just saw is called as the classification problems. Okay, so in the classification problem, what exactly happens is the result that we are trying to predict, right? This output is basically like a group or a class. Okay, so it is like I'm trying to predict whether they're all like we numbered this as 1, 2, 3. So we're trying to predict this class 1, 2, 3. Okay, or you're trying to predict whether, another example, if you take, you want to predict by pictures of dogs and cat, you want to predict whether it's a dog or it is a cat. Or here you're trying to predict the shape, or you were trying to predict the color. Okay, so like that we're trying to predict a particular, we're basically trying to group all of this into one category. Then we say that it is a classification problem. Okay, another supervised problem is a regression problem. So here the aim is to predict a continuous value. So here it is not a class, but it is a continuous value that you are trying to predict. Now an example for this is, say you have different attributes. Okay, so we want to understand whether a house, we want to know what is the selling price of the house. We want to understand its value. So for that, the value of the house, if you see, it can be any number, right? Some obviously it won't be very low as 10 rupees, 20 rupees, and all of that. But let's say it, starts from like around 10,000. You can have a house that you'll get for 10,000 rupees, or you can have a house that you'll get for 1 lakh rupees, or for 2 lakh, 3 lakh. The upper limit or the lower limit is really not fixed in this situation. Okay, and it can be any continuous number between this entire range. Okay, it can be any continuous number. So that is, this is an example of regression problem. So in case of regression, we are predicting a continuous value. Okay, and in case of classification, we're trying to predict a class. So example for regression was predicting the selling price of the house or the value of the house. But the example for classification is basically what you're seeing right here. You're trying to predict whether it's a red color object or a green color object or a purple color object. You can think of it in that way, or you can also think it of, you're trying to predict whether it's a triangle or a circle or a square. Okay, so this is basically what supervised learning is, and in our course we will be working rigorously on supervised learning only. Supervised learning is basically the part of machine learning which is most explored. Okay, so most of the algorithms, everything that is built is all in supervised learning. Okay, so most of the work happens with supervised learning only, where we give a lot of samples with the desired output, and then this algorithm we choose, and then the processing is basically to understand similarities, differences, and understand why something is being classified as what it is. And then for a new sample, again when I pass, it will say, okay, so for this sample that you passed, I think it belongs to, say, certain class. So it will give an output like this. So this is what is supervised learning. And it has regression and classification under them. Do any of you have any doubts? Okay, then the next topic that we have is unsupervised learning. So in unsupervised learning, what happens is that the target is not known. Okay, in case of supervised learning, we already knew what we're trying to predict, right? So that was already known at an earlier stage. We gave a lot of training sample where we had told that they are all triangles, they're all circles, they're all squares. You need to predict whether it's a triangle, circle, or a square. So this understanding is known when we are choosing the algorithm, when we're processing the data, all of that is already known earlier. So that happens in supervised learning. In unsupervised learning, no such information is already known. So basically what happens here is that we just give a lot of data and it will only push it into one of the sectors, and we should understand why it is pushed in one particular place. Okay, so basically here there is no supervisor and there is no person who's labeling all of these data outputs. So there is no labeling that's happening in the beginning, right? You don't see a supervisor on the top here. like we saw in this scenario. So that is not the case in case of unsupervised learning. Now the algorithm here is basically designed to interpret data and develop its own understanding of the data and process it into one of these groups. Okay. Now these groups are not known. Basically, in the beginning, only this input we'll give, and based on that, we'll get three different classes. And then we should understand why this samples have been grouped together. So that a human comes later. Okay. And any information, again here also, any information that we have which is not numerical or which is not a binary value, right? Basically any textual information you're having anywhere, we need to encode it into some type of a numerical value. So basically the machine doesn't really know what these groups mean also. Okay. So basically a lot of input data, then the algorithm does some interpretation and some understanding it will do purely on mathematical significance. Okay, because there are no words. First of all the words are put into numbers, so they're all just numbers that the computer has. Okay, and computer is very happy with just numbers. So it is basically, just pushing things into certain places based on the patterns it has understood. Okay, and it is basically noticing something is similar, some attributes are similar about certain samples, so it is pushing all of them together. So it will push these samples together, it will push some other samples here together, it will push some other samples here together. Now after all of this is done, then the human now comes and then he tries to understand, okay, these say 1,000 samples have all been put together. Why do you think these 1,000 samples are put together, and understand what is common between them. Most of the times it's very obvious why they have put something together, and then you'll know that, okay, this cluster, it has put them together because they're all triangles, and these are all circles, and these are all rectangles. This is one of the outputs that we could possibly get with an unsupervised learning. Earlier we discussed how an intelligent system is, incomplete, right, without a lot of data, that is this, and without a certain algorithm that is basically doing the process of going from an input to an output, and a human in the loop. So here the human in the loop was at an earlier stage where we would tell what are all the desired outputs for some things, right? It's basically like you're teaching what you're supposed to do at before only, and then you take on test. So that happened here, the human came earlier, but in case of unsupervised learning, all this processing, everything is done. After that, the final output that you're getting, you need to understand why you're getting this output, right? So then a human tries to come and sees what is common difference, and puts a name to these clusters. So in case of unsupervised learning, when we are basically putting similar things together, that is called clustering, right? What we had as classification in supervised learning is clustering in unsupervised learning. Now I hope all of you have understood the difference, how the human, before the human in the loop was at an earlier stage, and here it is at a later stage. So is it clear with the difference between supervised and unsupervised learning? Any doubts? You want to know how the data is classified in case of unsupervised learning, right? So in case of unsupervised learning, what happens is, based on this algorithm that you choose, again there also we have different algorithms. So what it will do is, it will see all of these samples and it will try to understand, say for all of these samples, we were having the height or the width and the densities. Imagine we had such attributes about it. Okay, so it will see all of these things and it will check the similarities, which things are more similar to each other. It will put all of the things that are similar together, and it will also see what are the things that are different from each other, they're totally distinct. something that's like a square or a circle might be little similar to each other, but a triangle is definitely very different from a square or a square or a circle. So it will put all the triangles very far away. Okay, so basically it will be very easy for this thing to split the triangles to one corner. After that, between again circles and squares that are remaining, it will try to see similarities, patterns. Basically, it's a lot of similarities that it is trying to find out, and it is trying to find out patterns between the data so that it can group all like ones together and unlike ones away from each other. So that is what the algorithm does. How the algorithm does it depends on the algorithm we have chosen. Okay, so in supervised learning also, like in case of unsupervised, there are a few algorithms, not as many as in supervised learning, because unsupervised learning is a stage, is in a type of machine learning where a lot of research is going on even now, and the number of algorithms that they have developed for unsupervised learning is much less compared to supervised learning. So supervised learning, and the next one that we'll see is reinforcement learning. So these two places are where the most research that happens in machine learning is all happening in these places only, and they're trying to develop more algorithms. It will understand using the algorithm. Okay, yeah, awesome. Okay, so then I think now we'll go ahead with reinforcement learning. Okay, so with reinforcement learning, I think it is better if I give you a different example rather than the shapes one. But I'll explain this whole structure of how there is a loop. Okay, so reinforcement learning is quite different from both supervised and unsupervised learning. Okay, so what the example we'll consider is that say a robot is trying to learn how to walk. Okay, so like basically it'll try to take steps, or you can even think of how first time when the baby is learning how to walk, it will try to take different steps, and maybe taking some steps is making the baby fall or the robot fall. So the robot will understand, okay, I should definitely not try to do this again, so I should do something else. So like that, it is trying to learn with experience. Okay, so this is how reinforcement learning works. So what basically happens is, for simplicity, let's say at every stage, okay, there are four different moves that the leg can do. Okay, so the robot's leg, now basically imagine now it's standing straight. Now it can either lift its left leg, or it can lift its right leg, and what angle it will lift its leg in, how much it will bend the knee upwards, different angles. So for simplicity, let's just imagine there are four different samples. Okay, but in reality there are so many different ways in which you can move your leg, and what will take you closer to walking. So there are so many different options. We'll consider that there are only four different options. Okay, each of these options, right, they're having a say a certain reward. Okay, if basically if this step is very good for you to go ahead, then I'll give you 5 points for that. Okay, and if you're taking some movement which is going to make you fall rather than walking, then I'm going to give you, say, a negative value for it. Okay, so it's basically called reward and punishment approach. So for all of these four different states that's there, uh, like let's say one has +5, the other has +3, the other has 0, and the other has -2. Okay, so we have these four options for the particular stage that we are in right now. For this particular state, the first state, when the robot is standing, for four options I have four different reward system that is there. Okay, now what will happen is you'll select the best action. So basically you want to make sure that you go ahead, right? So you will obviously, if you're having +5, +2, 0, and -1, you'll obviously select +5 because that is giving you more points. So you select the best action, and when you take this best action, it will take you to another state, right? So if you did +5, then it's basically moving your leg in some particular, say in some particular angle, or some other particular way. Okay, so let's imagine that you have lifted your ankle and you've bent your knee. So this is what happens in for the thing which you got +5 for. Now you're in a new environment. The same four options that you have, these four options will again be reassigned these rewards, right? Why is that happening? Because before, at that stage, if you had lifted your leg, that would have given you 5 points. But when you've already lifted your leg, if you lift your leg again, you might fall, right? There's no point if you're lifting your leg when you've already lifted your leg. So maybe now lifting your leg is having, say, 0, or it is having a negative value. Okay, and depending on how much you want to lift your leg also. And these rewards are again changed for this 4 different states. So before we had 5, 3, 0, and -1. Now we'll have, say, 2, 8, -3, and -6. Okay, so now you'll select 8, right? Because that is taking you more closer. So like this, you'll keep doing this again and again and again till you've reached your goal. Basically, imagine your goal that you have set for the robot is that the robot has to walk from, say, 10 meters he has to walk. Okay. So maybe he walked, like, 2 meters he walked, but after that he fell down. So then he'll again come back from the beginning and again start walking, like 10 meters from there he has to walk. So you'll do this again and again and again till your goal is reached. Okay, and once your goal is reached, you have basically got the output. So the agent is basically the algorithm. It's basically you're going to select the algorithm each time, which selects the best action as well and takes you to a new environment. And in this environment, all of the options that you're having, that will take you forward. Again, their rewards are always changed, and a negative reward means that you're going away from your goal, and a positive reward means that you're going towards your goal. So in the new state, based on the rewards that you have got, you will take up the best action, and that will give you a reward which will bring you to another state. So you'll go on continuously in this loop until you have reached the goal that the machine has set for you. Like in our case, let's imagine that you had to walk 10 meters. So until you walk 10 meters, you'll again start from first again and again and again and keep seeing. So these are basically the rewards that are being assigned. In the beginning, even the machine does not know what reward to give for which move. So it will understand based on falling down, like which step you took at what stage and you fell down. So based on that, it will keep making it more negative, and that is subtracting the reward. And if it is taking you to a better stage, it will keep making it higher, higher, higher. So in that way, the machine learns by making mistakes and learning from the mistake and continuously repeat again. So that is why we have a loop over here which goes on until the goal is reached. So basically, reinforcement learning, you can think of it as a game. Okay, and the game is that you walk 10 meters, and at every game, like, when you roll your die, you have 6 different options. Like that, every time you're having something, you have some certain of number of options, and you select one of these options, which basically take you more closer towards your goal. That is closer towards your end destination, if you think of it as a game. So any doubts in reinforcement learning? I've got fewer responses saying no doubts in this case. Any doubts, anybody? Please feel free to ask. Okay, then so with this, I think we reach the end of our presentation for today. So we'll conclude the discussion with machine learning part, let's make our laptops ready so that from tomorrow's class when we have to start the coding, that goes on smoothly. So basically, we have three different IDs that we can work with. IDs are basically these platforms in which you can perform coding. Okay, so so basically we have three different IDs that we can use. One is the Anaconda platform. The other one is using a Jupyter notebook. The other one is using Google Colabs. Now, because we're working with Python, there are so many other IDs also that is possible. Like you can use PyCharm, something else that you guys might have already used that you're comfortable with. But I suggest that all of you stick to using something which is related to Jupyter Notebook only. That is, I want all of you to stick to one of these three options, preferably than PyCharm or any other IDE. Only for the reason that when you're working with your project, you will have to do it on a Jupyter notebook only, so that you can do documentation along with your code cells. So that is why it is better if you people start off also with one of these ID options. Now you can stick to Anaconda if you're using say a Windows operating system. If you're using an Ubuntu operating system, then you can use Jupyter Notebook. Okay, or any other Linux based operating system also you can use Jupyter Notebook. Anaconda will be ideal for Windows, but irrespective of the operating system or anything, we can use Google Colabs. I will be using Google Colabs when I'm showing you, the implementation and all of that. So I'll be extensively working with Google Colabs. So I suggest all of you work with Google Colabs because this you'll be doing it on the browser. Yeah, you can use VS Code as well. There is no yeah, like I said, there's no restriction. Okay, but when you're doing your final project, right? So that time you have to do you have to have documentation as well. You can't only put the code cells. And you usually, having a report separately in like Word document will not be that nice, because I want all of you to be able to use this project. You should be able to put it in your resume. So that would be the main aim of your internship, right? So it will be better if you're using something which is based on Jupyter Notebook, so that you can upload it on Git or wherever you want to put it, so that you can show it to people basically. Okay, so and also you will understand the power of Jupyter Notebook once we start working with it. Okay, so Google Colab is basically a type of Jupyter Notebook only. It is offered by Google, and the thing is, most everything happens on cloud, right? So it's not like any of it is you don't have to install Python. Any installation on your system is not required. So basically, when you're starting off and you're not sure which of the IDs you will be comfortable with, you can start with Google Colab, and once you get comfortable with it, you can move to Anaconda or Jupyter Notebook. Okay, so because Google Colab is very light, only necessity you have is that you have internet connection. That is the only thing that you need for using Google Colab. Okay, no installation on your system. Even if your RAM, the like I said, computation is very important in case of machine learning. Even if you're having a system with like low RAM, or if you're having like i3 generation, anything you're having, the hardware will not matter so much if you're using Google Collaboratory. So even if you are using Anaconda or Jupyter, still you need to explore Google Collaboratory. So first I'll show all of you how you can, get an account in Google Colabs first. After that, we'll see how to install Anaconda and Jupyter Notebook. So and also the libraries that we will be using in this course are Pandas, NumPy, sklearn, and Matplotlib. So these libraries, all the installations are pre-done in your Google Collaboratory. If you're working with Anaconda or Jupyter Notebook, you need to check if Pandas, NumPy, sklearn, and Matplotlib. You need to check if these four libraries are installed. And if they're not installed, then you'll have to install it separately. So all this overhead will be avoided if you use Google Colab. Okay. So I'll share my screen. I'll share a different screen, and all of you, please open a new tab on your systems and go to Google. Okay, so that we can so that we can all use Google Collaboratory. Everybody has to do this step, irrespective of whether you're doing it on a Windows operating system or a Linux based operating system, doesn't matter. Everybody needs to first get your hands on with Google Collaboratory first, and then the next thing. So I'll go to Google first. I hope here we'll search for Google Colab. Okay. So once you search for this, the first link that you get, which is collab.research.google.com, right? So I want all of you to click on this. And once you click on the first link, it will automatically open. If you're opening this for the first time and your account is not synced with Google Collaboratory, then it will probably ask you to accept to some permissions. You can accept to any of the permissions that they ask. Okay, and once you accept to the permissions and you link your account, basically your Gmail account, when you link it with it, so it will open this welcome to Collaboratory notebook. Okay, so this will be the landing page that you guys will come across. Just a minute. Yeah, so you will get a page something like this once you've given permissions to whatever they ask in your particular account settings. They'll ask you some questions. Once all of you have reached the welcome to Collaboratory notebook, please put a message ready in the group chat so that I know all of you have reached this stage. Okay, so once all of you have got this welcome to Collaboratory notebook, here you can go to file and click on new notebook. Okay, so file, new notebook. Once you do this, it will redirect you to a new page which is going to have a new notebook. It will be named Untitled. So you will get something like this. If all of you have got something like this, then please put a message, got it, in the group chat. Okay, so basically the one cell that you're seeing, these things are called cells. Okay, so the first thing that you're seeing is a one code cell. What we'll do is we'll type print. Okay, and here we'll have a quote, single quote. Inside this, I will type hello. Hello world is usually the first program that you always do in any place. So once you type this, right, print, open parenthesis, single quote, hello world, and close the single quote and close the parenthesis. You don't have to understand completely what it is. Basically, it's a print is a function, and anything that we pass inside the parenthesis, it will print that value. Okay, and we want to print a string. String is like a series of characters. So for that, we have included them inside single quotes. So once you have typed this, there is this play button which is on the leftmost side. So if you just click on that play button, right, you will get something like this. It's connecting to runtime and it will give you an output. Okay. So you will get this hello world output. So if all of you have got this, then we are good to go. Okay. If everybody gets this output, put a message done in the group chat. If any of you have got stuck at an earlier stage at some point, feel free to ask me. If all of you have completed till here, then that's great. Okay, so basically, all of you are good to go to do this internship. Okay, all you need is Google Collaborate to do it. So if the setup is done, then that is amazing. Okay, so if you want to install it, right? If you want to install it, then if you want to use Anaconda or Jupyter Notebook, I suggest that if you're using Windows operating system, you should use Anaconda, and if you're using Linux-based operating system, you should use Jupyter. So, is there anyone who is using? So, dual boot means you have Windows and you have that, right? So, okay. Anybody with only Linux operating system? Okay, I don't think anybody is having such a scenario. Okay, so most of you will, if you want to install apart from Google Collaboratory, then you can just use Anaconda. So I'll just show you how to do that. Again, you go to Google, and here you can search for Anaconda. Okay. So here again, you need to click on the first link, that is anaconda.com. So we'll click here. And here in products, you can check for the enterprise edition. Okay. And here you basically have to yeah, so you need to choose individual edition, and after you choose individual edition, you scroll all the way down, you will get this download option. Okay, so you click on the download option, it will download an exe file in your system, and once the downloading is done, you can run the exe file, and then I'll tell you what is the setup that needs to be done. So I won't be downloading it, but I'll guide you through every step. Okay. So whoever wants to download the Anaconda in your system as well, please click on the download button here. How do you reach this place? Is you go to Google, search for Anaconda, open the first link, and then on the top navigation bar under products, select individual edition. Okay, and just scroll a little down, and you will get the download option. And once you have downloaded and the exe file is ready in the system, please put a message ready in the group chat so that I know I can tell you the steps from there. Any of you trying to do it with Anaconda as well? Can you please raise your hand so that I know how many of you are doing with yeah, if you want to do it right now, you can do it along with me. Otherwise, you can do it after class as well. That's not a problem. Yeah, Google Colab is enough for the internship. Okay, you don't need to install it on your. You don't need to install Anaconda. It is not compulsory. If you want to do it, like every time you don't want to connect to internet and do it. Some of you will probably be using data. So if you don't want to always, if you have that constraint and you wanted to do in a downloaded environment, only then you install Anaconda. Okay, so I think 2, 3 people are installing. So 2, 3 people are installing the Anaconda. So once the exe file is ready in your system, please put a message ready in the group chat. Basically, what you'll have to do is you need to double click on the exe file and run it, and you just have to go next for anything that they're saying. You don't have to choose anything and complete the installation process. Okay. So you do that, and after you've completed installing, directly put a message that time only in the chat. And then I'll tell you how you can open your Jupyter notebook and come to the same place like how we saw in case of Google Colab. So once you complete the installation, please put a message ready in the group chat. Once if you are installing Anaconda, can you please put a message on the group chat? If none of you are doing it and if all of you are going to stick to Google Collaboratory, then we're done with today's class. If any of you are still installing Anaconda, and then I can give you the steps for after that. So if you are just using Google Collaboratory, we're done with today's class. You can leave this session. Any of you who are still working with Anaconda can stay back in class until they complete. Thank you. So Harshita, what you need to do is in the search place you search for Anaconda Navigator, okay, and you click on the Anaconda Navigator. It will open something like this. We can share my screen. In the search bar that you have right there, you search for Anaconda Navigator here. Here you search for Anaconda Navigator. If you have already installed it, it will come here, okay. Because I have not installed, I won't search for it. So once you get that, you'll click on the Anaconda Navigator. It will open something that looks like this. So let me know if you get this page. Okay, so once you get that right, you'll get this option of launch. So there is Jupyter Notebook and there is Jupyter Lab. You need to click on Jupyter Notebook. So you here there is this launch button. So you click on that launch button and you will get a page that looks something like this in your Chrome browser. So you should get something like this once you click on launch. Once you get that, please let me know. Yeah, okay, awesome. So once you get this right, here you have this option called new in the right side top. Okay, so there you click on that new and you select Python 3. So it will basically open a Python 3 notebook that will look very similar to how the Jupyter notebook looked in case of Google Collaboratory. So click on new Python 3, it will open a new notebook. It will have again, I think, untitled only. And there you can, check for print statement. If it is working, then you're good to go, Harshita.